Just making a quick correction on the last video, which was the first video in the numerical modeling playlist. When I was talking about the Navier-Stokes equation, um, I made some mistakes on how I determined where things were located on the cell or face. So for this, we're integrating from I minus 1/2 to I plus 1/2. That's on the edges. And so we end up getting a value that's volumetrically averaged into the center of the cell. So U is on the face, then this whole quantity would be on the cell, as we see here. Then if we look at the advection term, U is on the face. And so U is also on the face. So we basically do U at the edge times U at the second edge minus U at the first edge divided by our dx. So that will actually also put it on the cell. And for pressure gradient, though, P is on the cell, so we should first interpolate it onto the edge. And then that will give us, taking the derivative from edge to edge, will actually give us a value on the cell. So now we have it matching up where it's cell, 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 and it works out here. This is pi plus 1/2. We don't have pi plus 1/2 because it's located on the center, which is I plus 1 or I, not at I plus 1/2. So then we do the interpolation to get the P average, the average pressure. So it would be, go up 1/2 and go down 1/2. So I plus 1/2 plus 1/2 is I plus 1. I plus 1/2 minus 1/2 is I. And then you take that, you add them together, divide by 2, that's the average. And of course there are better ways to do an interpolation other than just the average. But for example, you could use multiple values of I plus 1, I plus 2, etc. But this actually works fine for pressure. But if you're looking at other things like U, for example, you have to be very careful how you interpolate, because that could mess up the simulation, I think. But anyways, this is fine because pressure is very, I'm not sure I don't think it needs to be a conserved quantity or anything, so I think it works fine for this. But I'm not sure because this convention that I made up here to try to get things to work, maybe someone makes their own numerical model, maybe they do something different. Maybe they put this one on the face, this one on the face, and this one on the face. So anyways, in a future video, I'll try to talk about one, try to talk more about that, I'm also going to introduce this more general method of FVM, and maybe that will clear this up. So thank you, and sorry for the mistake, and hope you enjoyed the correction, and stay tuned for future videos.